This video clip shows how to estimate the rate of change from a graph. Suppose you keep track of the number of homes in Blanding over time, maybe each year, and then you want to know about how many new homes per year so you can plan for electricity or gas or water. A city planner might want to know something like that. So the first thing we do is draw a line that approximately matches the data. You can see that that data is not a straight line, but if we drew a straight line so that some of the points were above and some of the points were below, maybe that would give us a pretty good estimate. Then what we do is we find the slope of that line. Now, that point on the line, where the line goes right through a grid, is maybe a good one to use. It happens to be on the point also, but that's not necessarily required. And that one we could estimate it's between 900 and 950. It's closer to 900. What is it, 910? So if we look over, we see 1050 in 2006 and maybe 910 in 2001. So to find the rate of change, we would find how many new homes. So 1050 minus 910 and 2006 minus 2001. So that's a difference of 5 years, and the difference in the number of homes is not quite 150. It's about 140 homes in 5 years. Five goes into 140. 5 goes into 14 twice. 2 times 5 is 10. 14 minus 10 is 4. Bring down the 0. 5 goes into 40 8 times. So we think that an estimate is about 28 homes per year. It's not always the same, but for planning purposes, that would probably be a good number to use if that data were really what the number of homes. Well, let's say we measure a tree over time. Every 5 years, we take a measurement on its height. The first year we started off by measuring it. It was 25 feet high, and so let's match that data to maybe a straight line that goes something like that. We have points above, we have points below, so maybe that's somewhere, maybe that's an average. Remember, this is an estimate, it's not exact, so if you get an answer that is not the same as somebody else's, just look to see if it's close. Well, let's look for places where that crosses right on a grid. I'd say that's a pretty close to 45. That's pretty close to 25. So let's use, and so that was after 20 years, 45 feet after 20 years, 25 feet initially. So let's do the difference in the height. 45 minus 25 divided by the difference in the years, 20 minus 0. So the difference in the height would be 45 minus 25 is 20. So 20 feet in 20 years. So that's about one what? 1 foot per year. You can see that tree did not grow a foot every year, but on average, that's close. Sometimes it didn't grow quite as much, sometimes it grew a little more. How about an airplane coming in for a landing? Starts out at 1,000 feet high and is coming down at a certain rate. Let's see, let's look for, well, let's use that point. It's pretty close to a grid. That line goes about through the grid, and that line goes about through the grid. So the grid is where we've marked right at 30 and right at 250. So let's look at the change in elevation. The elevation was 500 at 20 seconds. The elevation was 250 at 30 seconds. So what that tells us is we have a change in elevation of 250 and a change in time of negative 10. Well, what does that mean? Well, what that really means is that the elevation has dropped. So if we go ahead and the zeros represent times 10. 10 divided by 10 is 1. So that comes out to be negative 25 feet per second. So that is a negative rate. It's getting lower as the time goes on. So that estimated rate of change is about down 25 feet every second.